let's start to finally solve the last two questions. So let G be a differentiable function of two real variables, and F be a function of complex variable Z. And F is analytic. So basically, this tells you that F of Z is a function of Z. So you can use the Cauchy-Riemann equation. But if you don't know that, it's still okay. Because you know that there is an exponential x sine y term, so you can guess the answer. You can guess the answer. F of Z must be some c times exponential z. And the z is equal to x plus iy. Okay, so that this term can be written as c exponential x cosine y plus exponential x sine y. There's I term, and you see that the first term in here is exponential x sine y. So this tells you that this c should be minus I, because the minus I squared is 1. So you know that the I of G should be this part, minus I exponential x cosine y. So G is minus exponential x cosine y. So this is the answer. Okay, then we plug G32 and the G12. And we minus them, so we get E. So we choose E. Very simple. Okay, so here comes this final question. Z17 be the ring of integers modulo 17. Z17 times be the group of units under multiplication, which the following are generators. So this problem can only solve by brute force. So I will link below that the multiplication group structure. But in general prime number, there's no simple rules. So Z17 contains the 0, 1, no 0. Up to 16, and they are closed on the multiplication. So the generator means that when you keep square or keep times this generator, it will become the whole group. So we want to find A such that this A is generator. We produce a set. Is the whole set. This is called a generator. So we need to check if 5 is a generator, or 8 is a generator, or 16 is a generator. So we first see the simple example that 16 is not a generator. Okay, so x16 is 16. What is 16? If you do the 16 squared modulo 7, this is the same as minus 1 squared modulo 17. So it's 1 modulo 17. So S16 only contains 16 and 1. So it's game over, because 1 squared is still 1. So this is not the same as. So 16 is not a generator. How about 8? We have 8. So 8 squared is 64. 64 modulo 17 is 13. And the 13 need to times 8. So it's 104 minus modulo 16 is 2. And your times 8 is 16. And 16 times 8 is 128. And modulo 16 is 9. And the 9 times 8 is 72. Modulo 16 is 17 is 4. 4 times 8 is 32. Modulo 17 is 15. 15 times 8 is 120. Modulo 17 is 104. 102. 119. No, it's 1. Yeah. Right. So it's game over. This is not the whole group. Finally, so the only remaining possible choice is 5. 5, 25, 8. 8 times 5 is 40. 40 modulo 17 is 6. 6 times 5 is 30. 30 modulo 17 is 13. 13 times 5 65. 65 modulo 17 is 14. 14 times by 70. 70 modulo 17 is 2. 10. 50 modulo 17 is 16. 80 modulo 17 is 12. 12. 60 modulo 17 is what? It's 9. So basically up to here you can already guess 5 should be the answer. Because the generator, the number of S will be a subgroup of Z17. So Z17 has 6, the order is 16. So if S is larger than 8, then S must be the whole group, and E already larger than 8. But I guess I will still do the rest of this. So 9 times 5 is 45. 45 modulo 17 is 11. And the 55 modulo 17 is 4. And the 4 times 5 is 20. 20 modulo 17 is 3. 15. 45 modulo I missed something. Let me see. So 11 times 5 55. 55 modulo 17. Oh, it's 3. It's 4. Right, it's 4. So 4 times 17, 4 times 5, 20. 20 modulo 17 is 3. 3 times 5 is 15. So 75 modulo 68. 17 is 7. And 35 modulo is 1. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yeah, so we have 16 numbers. So 5 is a generator. Okay, So we already finished all the subject GRE math, and please subscribe to my channel if you like it. Thank you very much. I will see you in the next video.